So this is the first problem of today's Codechef Starters Div 2, and in this problem we are given that recently we read about the Caesar's cipher, and one of the first and the easiest to break cryptographic, like Caesar's cipher is nothing but one of the easiest and first way to break cryptographic algorithms. And since it was too weak, we decided that we are going to improve it by building a light version of it. So the modified algorithm is, suppose we want to encrypt a plain text P of length, then first we generate a secret cryptographic key K, which is an array of length n. Then for each I from 1 to n, we perform Ki Caesar 3 shifts. Now what is a 3 shift? A 3 shift is nothing but you just replace the current character with the third next character in English alphabet. So if it's A, it will become B, C, D, D, and like this. And this is done cyclically. So A is assumed to be next character after Z. So for example, the 3 shift of Y will be B. How? First you'll get Z, then you'll get A, and then B. So this is the 3 shift on Y. So now let's denote the encrypted ciphertext of a plain text P using key K as E of KP. So if E of K on pass will be fail. How? If you do like if this is K, you have to do like on P you have to apply 3 shift 40 times. So it will become like we are not actually going to apply this, but it will become F. And if you apply it 0 times, it will remain same. If you apply it 14 times, on S, it will become I, and if you apply 15 times, then it will become L. S will become L. So now after a long time, we have forgotten what was the original K, like this array. But we know the original plain text and the encrypted ciphertext. So we have to find the lexicographically smallest array K for which E of KP is C. So first of all, like then it's shown that it can be proven that such kind of K always exists. And the second thing is, like, what is the definition of lexicographically smaller? So let me explain this here. So everybody knows what, like, if let's say there are two arrays A and B, how we can say that A is lexicographically smaller than B. Basically, if both these arrays have same size, then the position at which these two differ, A is less than B. This prefix is same. This part doesn't matter. So this is lexicographically smaller. Now the second thing is, why does the answer always exist? See, if you start from A, after how many moves you will come to close to Z? Anyone, any idea? If you start from A, so B, C, D, E, F, G, like this, if you come, probably you'll like, what can someone tell me what will be the last character before C that you land on? So is it Y? Like first you'll get A, then after 3 shift D, then after 3 shift G, then J, M, P, S, V, Y. Is it right? Or have I missed something? It's right, right? So after this, you'll get B. And then these will be the characters that you'll get: B, E, H, K, N, Q, T, W, and Z. And next time you'll get this C. then FILORT, not T, U and X. So see, you are getting all these 26 characters. Like you will definitely get every character out of these 26 characters. You're not missing any character. So let's say you were currently, you started from some character X and you wanted to end at some character Y. So in 26 moves, you will definitely land there. So what you can do, you can initially like just brute force, just keep doing like if you are at some character G, just move to the character which is third next to it and increase your count by 1. Once you end up after Z, just make sure that you are landing back here. So till your both characters are not same, keep doing the 3 shift and increase your count by 1. Finally, once your characters become same, you can print your count. Is that clear? Yes, no? Or is anyone having any doubt in this? It's clear, right? Okay, so let me show you the implementation. So this is the implementation. In this, I have first taken the test cases as input. Then this is the length of the strings. These are the two strings. Now for each character, I have first declared a count variable, which is initialized to 0. Then while my both characters are not same, I'm increasing my count by 1 and I'm increasing this character by 3. So this is like just adding 3 simply means like this is a character, right? So if you add 1 to a character, it will shift 1 and like 1 next. If you add 3, it will shift to 3, the third character, the third next character. And if AI is more than Z, then what I'm doing, I'm making it A plus whatever it was more. But just do a sub -1. Why? Because right after Z is A. So if your AI is 1 more than Z, then I have already written A here. So just do a -1. So how whatever is more than this, just cyclically rotate it back to start. Finally, once my both character becomes same, I will have the number of times I have to apply this operation. I have to cyclically shift it, and that will give me the minimum number of times, right? So that's why I'm just printing it here, count. So is it okay? Okay, so let's go to the next problem. So this is the next problem. In this problem, we're given that we have an array A of length n, and in one operation, we can swap any two elements if they are not adjacent. That is, we can pick any two indices I and j such that j minus I is more than 1. That means they are right, like they are not right next to each other. So we need to find using these operations any number of times. Is it possible to turn array A into sorted array? So we have something like this array, let's say, and we can swap like this element cannot be swapped with this. Otherwise, this can be swapped with anyone. And this is true for every adjacent. Like these two cannot be swapped. Otherwise, this element can be swapped with anything on here and here, but cannot be swapped with this thing. So we need to find whether it's possible for us to swap whether it's possible for us to sort the array or not. So if we look closely, like let's say you're given two elements. Can you swap these? Yes, no, no, right? Okay. So let's say you had something like this. The first element is more than the second element. So your answer will be no, right? Any doubt in this? If you had a single element, let's say anything, let's say a 9, your answer will always be yes, irrespective of this thing, if you just have one element, right? And if you have 3, now can someone tell me what happens if 3? See, you can swap these two any way you like. You can arrange these two any way you like. What is the condition? The condition is only that if this element, let's call this as A, this as B, this as C. If B turns out to be less than minimum of AC, or if B turns out to be more than the maximum of these AC. In these two cases, your answer is no. Otherwise, else your answer is yes. Why? Because this B, whatever this B is, it's in between AC or equals to AC. So you can always rearrange these two and B will lie in between or is equal. So in those cases, your answer will be yes. Otherwise, if these two are the cases, then your answer is no. So are these three cases clear for when n is 2, when n is 1, and when n is 3? Now, what about other cases? See, my claim is that if n is more than or equals to 4, the answer will always be yes. Why? See, whatever it is, first of all, if there are more than 4 elements, will like always like see whatever number I want here, maybe it will be here, anywhere. I'll always bring it here, and then I'll swap these two. Then I'll swap these like this. Then I'll whatever number I want here, I'll first bring it to the first place, and it's always possible because I have 4 numbers here, right? I'm leaving these 4. So this part can be sorted, and now this 4 is left. So it's also always like it's always also possible for me to swap. Why? Because what I'll do, whatever number I want here, first I'll fix it here, and then this problem becomes really easy. Why? Because then I'll fix this number. How I can fix this number? See, either this number will already be here, or it will be here or here. So if it's here, I'll first bring it here and then bring it here. Or if it's already here, then I'll directly bring it here. Now the thing is, this is correct, this is correct. Only ambiguity is between these. If they are also correct, then the array is sorted. Otherwise, if these two are not at correct places, I'll swap these two. But the thing is, if I have more than 4, I can always sort. Is it clear? Like this is one of the ways. Is it clear? What about others? So let me show you the implementation. So first I have taken the number of test cases as input, then the number of elements in the array. So I'm checking for this condition first, that if n is 2 and the second element is more than the first element, then the answer is no. Otherwise, if n is 3 and one of these is true, that is either the middle element is less than the minimum of first and third, or it is more than first and third, the answer will be no. Otherwise, the answer will be yes, always. Is it clear? Okay, so let's go to the next problem. So this is the next problem, and in this problem, we're given that an array A of length n is called frequency if for each I from 1 to n, the frequency AI equals the number of its positive divisors. For example, this thing is frequency array. Why? Because 1 has one divisor, and how many times it's appear? Like it appears exactly once. 2 has 2 divisors, and it appears twice. 8 has 4 divisors, and 8 occurs 4 times. So this way, this is a frequency array. Now, what we are given? We are given an array of, like we are given in an integer n, and we have to find any frequency array of a of length n such that the number of distinct elements in that array is maximum. And the number of, like the array that we should print should have all the values between 1 and 10 to the power 6. So let me explain first of all what is a, see, a frequency array is nothing but a frequency array is frequency, let me write it. frequency of each element is equals to number of divisors of that element. So if I decide that I'm going to write 36, like there's a number which is like a 36 is in my array. So what all divisors does 36 have? It has 1 divides it, 2 divides it, 3 divides it, 4 divides it, 6, 9, 12. What else? 18. And after 36. Is there anything left? No, right? Okay. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 divisors of this. So 36 should be 9 times in your array. If you decide that 36 is in your array, then it should come 36, like 9 times. So by this, and I want maximum number of distinct elements. So n is fixed, and I want to maximize distinct elements. But let's say your n was 9. So is it optimal that you should write 36, 36, 36, 36 like this? No, right? Because then you just have one unique element. So indirectly, you have to keep elements in this array such that they have least number of divisors. Is it making sense? Then because if they have less number, like lesser number of divisors, then they will come less number of times. Why? Because the number of times that they have to come should be equals to their number of divisors. And if they come less number of times, then there will be more elements, more distinct elements. Is it clear? Yes, no? So now we have to place such elements in my array such that they have least number of divisors. So can someone tell me what are those numbers which have like less, like which have only, let's say, 1 or 2 divisors, which have only 2 divisors? What are those numbers? Like first of all, can any number like except 1? Is there any number which have just one divisor? Everything is divisible by 1 and itself, right? So there are, except 1, there every number will have at least 2 divisors. And which all numbers have 2 divisors? Those numbers are primes. So it's always optimal for me to keep primes in this. See, I'll keep 1 in this. Why? Because I get one unique element and 1 will simply come like this, right? If you have 1, 1 has only one divisor 1, and its occurrences also, like frequency, needs to be only 1. Other than that, I'll keep every prime, like p primes 2 times. P1, prime 2, prime 3, every prime 2 times. Why? Because primes have the least number of divisors. So every prime needs to come twice. And now you might say, like, should I keep any prime? Yes, you can keep any prime. And by constraints of this problem, n is less than or equals to what? N is less than 2 into 10 to the power 4. That is around 20K, right? 20,000. Yes, this thing. And AI, like the maximum number that you can keep is up till 10 to the power 6. So there are more than these prime numbers. There are far more than these prime numbers in this range, 1 to 10 to the power 6. So what you can do, you can just, first of all, using C's method, find the primes, and then once you know the primes, just iterate through from 1 to, let's say, 10 to the power 6. And if the ith is a prime, just print it. And once you have printed, like if I is a prime, print I twice. And once you have printed n numbers, just exit this loop. But the thing is, if you look at this kind of arrangement, there is one issue. What is that? The issue is, if I do like this, like first I print 1 and then I print these numbers, these primes, I'll always end up printing odd because I cannot print this prime only once. Why? Because let's say 5 is a prime. I cannot print it just once. because 5 has two divisors. I need to print it twice. So one thing that you can do is either don't print this one in case of even, if you want even numbers, and print just primes. Or what you can do, one other way is start from 1 only, and you can do this thing. Like this will also give you the same result. If n is more than or equals to 4 and n is even, then first print 1 and then print 4. This 4 has three divisors, that is 1, 3, and 4, and you can print it 3 times. Like eventually you have taken 4 places and you have got two unique numbers. If you would have done something like 2, 2, and 3, 3, then also you have two unique numbers and you have taken 4 positions. So either just print in case of even, don't start with 1, just start with primes and print every prime twice. Otherwise, you can also do 1 and this 3 times 4 and then do the same thing. Just print primes twice while you reach n. In case of odd, just start with 1 and keep printing primes twice. Is it clear? Yes, no? Okay, so let me show you the implementation. So this is the implementation. I have first taken the number of test cases as input. Now this is my sieve method. So I'm going from 1 to 10 to the power 6. If the ith number is not prime, then I'll simply continue. Otherwise, if ith number is prime, I'm marking every multiple of I as not prime. So this is the usual sieve method. And then I'm for like, make sure that you're doing this calculation outside your test cases. If you do this inside, then your time complexity will become 10 to the power 6 into the number of test cases. So you'll get TLE. So for each test case, just take the number of elements input. If n is 1, you can simply print 1. If n is 2, you can simply print 2. You don't have to consider all of these corner test cases. If you do that thing in case of odd, simply print 1 and then primes, like every prime twice. In case of even, don't print 1, just print the primes twice. But I have separated these corner cases. In case of 1, printing 1. In case of 2, print 2 twice. In case of 3, print 1, 2, 2. Otherwise, for all test cases, first print 1. You have printed one element, so done is 1. Done is nothing but the number of elements that you have already printed. Now, in case of even, n will be more than or equals to 4, right? Because I've taken care of 1, 2, and 3. So if n is more than or equals to 4 and n is even, then my done is increased by 3 and I have printed 4. So this is that thing, 1 and then 3 times 4. And for all the remaining elements, while my done is less than n, I'm simply printing the primes. Like if I is prime, increase my done by 2 and print this prime. I is a prime, right? So print I twice. Finally, I can like just for this test case, once I'm done, I'm just printing an empty, a new line. Is it clear?
I wanted to ask, just like before you have created the S prime vector, can we use another vector prime for storing the prime number? Like
Yes, yes,
whenever,
yes. Yes. What you can do here, instead of iterating like this, you can store these instead of iterating like this, then you can iterate over just those primes. You can store these primes here. Like you can have another loop and just check if prime of j or prime of I, then insert in primes vector. You can do it like
I
that.
was doing the same, but I was getting runtime error.
So like then there would be some fault in your like implementation, but
Like
that thing
when
will also work 100%.
like
I'll
initially 2 printed, 3 printed, but after that the whole array was 0.
I was not able to understand you.
Like when I printed for n means for n equal to 8, then answer was like 2, 2, 3, 3, but then all the 4 elements were 0.
Okay,
Means the
then definitely like it's definitely like there is some issue with your implementation. So we'll do one thing after the session. Like you can just raise a query and ping me in it. Like I'll have a look at your implementation. Okay.
Okay.
Any other doubts? Okay, so let's go to the next problem. So this is the next problem, and in this problem we're given that chef has an array A of n positive integers, and he can perform the following operation at most once. That is, select an index I and an integer k. K needs to be more than or equals to 1, and select k non-negative integers x1 to xk such that 2 to the power x1 plus 2 to the power x2 all the way up till 2 to the power xk is equals to ai. And then finally erase ai from array A and append these terms in array A. So one thing that has to be noted is these x1, x2, all the way up till xk are not unique. Like 8 can be represented like 2 to the power 1 plus 2 to the power 2 plus 2 to the power 1. Now chef wants to maximize the bitwise XOR of all the elements of array A. After performing this operation at most once, so we have to find what is this maximum value. So first of all, see what is being done. There is an array A. One of these elements is selected. Let's say it is AI, and AI is written like 1 plus 1 plus 1 plus 2 plus 2 plus 4 plus 8 plus 8. So this is written like 2 to the power 0 plus 2 to the power 0 plus 2 to the power 0 plus 2 to the power 1, 2 to the power 1 plus 2 to the power 2 plus 2 to the power 3 plus 2 to the power 3. And then this AI is removed from this, and these terms are inserted, or these terms are inserted in place of this, and then the XOR is taken. So we have to maximize XOR. Now, what is the benefit, like how to maximize this thing? The first thing is, see, let's say you cannot magically, like if there is, let's say in your final XOR is something like this. So you cannot magically just set this bit. You have to, what you'll have to do, if at some position, like why is this bit unset? Either it is unset in every element or it is set in even number of elements, right? These are the two cases. Either it is not set in any element or it is set in even number of elements. This is the final XOR. So let's consider this case. If this is the case, then you cannot magically set this bit. Can anyone tell me why? See, how you can influence this. If let's say there's an element which had this bit set and you decided that you're not going to set this, then first of all, you'll have a disadvantage. Why? Because then eventually, like earlier, here there were odd number of set bits. Now there will be even. So this bit, instead of being 1, it will become 0. And as we already know, like if like I'm writing these this way, are the bigger bits. This is the most significant bit, and this is the least significant bit. So let's say this is 2 to the power 0. This is 1, 2, 3, 4, 5, 6, 7, 8, 2 to the power 8. So I always want the bigger bits to be set, irrespective of what are the smaller bits. Why? Because I know that 2 to the power 8 is more than 2 to the power 7 plus 2 to the power 6. All of these added up are not more than this thing. So that's why I will never unset this to set the lesser significant bit. So I won't change this. But what I can do, if this is the case, I cannot do anything. But if this is the case, can someone tell me what I can do? Two elements have this bit set, and eventually the XOR in XOR this bit is unset. Can someone tell me what should I do? You can take one of these numbers, and in that, instead of having this bit, like let's say this is this bit, you can have the, like you can break this number and write these two, like let's say this is x1, you can write this as 2 to the power x2 plus 2 to the power x2, this bit, right? What will happen eventually in XOR, you will have these bit will occur odd number of times, so you'll get a 1 here. Yes, no, anything? And the rest of the bits won't have any effect. Why? Because if you remove this one bit from here, the next bit will come twice. Like you'll have to write 2 to the power x2 plus 2 to the power x2. x2 is nothing but x1 minus 1. Like if let's say x2 was 3, x1 will be 4. This is 2 to the power x2. That is 8. This is 16. So you'll have to write 8 plus 8 to get 16, right? So that's why I'm saying if you remove this bit, let's say this is the fourth bit, 2 to the power 4. So if you remove this one, you'll have to write 8 and 8. So this is eventually coming even number of times only. So there will be no effect on this. But what if you want some effect? What if here you also had a 0? Then you again will like just keep one thing here, and the next one 2 to the power x2 will again get carried down to further 2 to the power what, x3 plus 2 to the power x3. You again look down, okay, you want, there is a 0 here, so keep 2 to the power x3 here only and break this further down, 2 to the power x4 plus 2 to the power x4, right? Here you have a 1. So what should we do if we have this thing? Can anyone tell me how much should be left here and how much should I carry down ahead? Here I was able to get 1. Here I have already received 1 at 2 to the power x4. I have two things here, 2 to the power x4 plus 2 to the power x4. If I leave both of these, I'll get 1. If I leave both of these, like you'll get 1, no effect on XOR. But if I leave both of these, then there will be 1. If I leave one of these, then this bit will get unset. So what should I do? Should I leave both of these here only? Like, should I get, like in my AI, this is my AI, right? Should I break it like this? Like, should I have 2 to the power x4 plus 2 to the power x4 in it? If I have 2 to the power x4 plus 2 to the power x4 in it, this bit will remain unchanged. If I have just one of these, then this bit will unset. What should I do? Should I leave both of these like this one, 2 to the power x4 plus 2 to the power x4? Should I do like this? Then the XOR will have no effect here, like no change here, because this bit is getting, like, it has been added twice. What should I do? Okay, somebody has written up to next set bit. Can you explain what like you can unmute yourself? Okay, you mean that up to next set bit will go on and then we'll stop. But this is not efficiency. You have 2 to the power x4 here. Why not shift both of these here? Why? Because you can set every one of these. How? You have like 2 to the power x4 was twice here. So you get 2 to the power x5. x5 is again like x5 is x4 minus 1. So 2 to the power x5 plus 2 to the power x5 because of this, and 2 to the power x5 plus 2 to the power x5 because of this. Now carry on these three forward and just leave this thing. Why? Because this is 0, this will become 1. So you carry these three forward, and here you'll get 6 times 2 to the power x6 plus 2 to the power x6 plus 2 to the power x6. My point is, if you have already 1, then take everything forward. If you have 0, then leave one thing and carry the remaining. This way, you'll get, after this one, you'll get everything 1. Is it clear? Okay, now it's clear. But there is one issue now. You cannot do this with the last. If you had last bit 0, you cannot say that, okay, I'll leave 1 here and I'll carry on everything afterward. So I'll get a 1 here also. No, you cannot do that because there is nothing after this. After this least significant bit. So just do up till this point, and you cannot change. If you had a 0 here, it will remain 0. If you had a 1 here, it will remain. You cannot change whatever you're getting here. But up till here, you can change everything once you get up. Like, what is the starting point? We started from that point which had 0 in XOR, like for which the bit was 0 in XOR, but it was set in some values, like in some array elements. Like that bit was occurring even number of times. And by even, I mean more than 0. So we started from that point. After that point, we will set every bit, except we won't change the last bit. Is it clear? And that is the final and the maximum XOR that we can get. Is it clear? Okay. So let me show you the implementation. So this is the implementation. In this, I have first taken the number of test cases as input. Then I have taken array A as input. Then this is my value. This is nothing but the XOR. This is the XOR, like initial XOR of array A. Then I'm going through every bit and I'm checking what is the number of, like the count, how many times that bit occurs in array A. So I'm iterating through all the elements and I'm counting how many times this bit has occurred, this bth bit, this bit has occurred in array A elements. And I'm going from 60 to 0. Why? Like 60 to not 0. Actually, I'm stopping before 0 because of the same reason. I cannot change the 0th bit. That is the least significant bit. And why I'm starting from 60? Because it is the most significant bit. So I'm going from most significant bit to least significant bit. And actually, you don't have to start from 60. You can start from 59 also, because the array, like the array elements are less than 2 to the power 60. So going from most significant bit to least significant bit, count how many times this bit occurs in array elements. And then if it occurs even number of times and it's more than 0, I'm marking this check as 1, which was initially, you can consider this as false and this as true. After this, once my check is true, I'll always set this bit in my val. Val is nothing but the XOR. Finally, I can print my val. I'm not going through the least significant bit, so that will remain unchanged. Is it clear? Okay, perfect. So that's it, and thanks for joining. Bye bye.